we need to look at what happens when we solve equations with more than one operation, because it's going to happen often. For instance, in this problem, we know we need to get x alone. Who's keeping x from being alone? The 3 is, he's multiplying x, and the 7, he's adding to x, if you would. Which one do I get rid of first? We know from the past that order counted. At first thought, you hopefully go right back to say, well, the answer here is to use the order of operations. Well, remember, we use the order of operations to do a problem. Remember the order of operations? The first thing we do is parentheses, and if there's more than one parentheses, we work left to right. Then we do exponents, and once again, left to right amongst ties. Then we do any multiplications and divisions. Now remember, you don't always do multiplication before division. It's just that if there's more than one, amongst multiplication and division, you'll work left to right. Same thing with addition and subtraction. And the last thing we do is simplify any fraction. Well, that's to do a problem. We're going to go in that order. When we solve an equation, we're not really doing a problem. We're still going to use the order of operations. But we're undoing a problem. We're getting rid of things to get x alone. So we're actually going to follow the order of operations backwards. Yes, you do need to know, as we told you before, the order of operations forwards and backwards. Later on in the course, actually the first thing we'll do to solve an equation with a fraction is get rid of the fraction. But we're not going to do that just yet. So hopefully you can see the first thing we're going to do is get rid of any additions and subtractions, because we're working backwards, and then we'll get rid of the multiplications and divisions. Recall that we are trying to get the variable alone, so we're undoing various operations. Remember how to undo operations? The opposite of addition is subtraction. The opposite of subtraction, quite obviously, is addition. What about the others? The opposite of multiplication, even negative multiplication, is division. And the opposite of division, we'll see later, is multiplication. Okay, let's take a look at this. And we're going to get x alone by following the order of operations backwards. Well, we see that we have two numbers, if you would, keeping x from being alone, the 3 and the 7. We're going to do the order of operations backwards, so we're going to get rid of our addition first. The opposite of addition is subtraction. Of course, if I do it on one side, I have to do it on the other. So let's compute this. The 7 will in fact go away, and 43 minus 7, we have 3x equals 36. Now the only troublemaker we have to get rid of is the 3. He's multiplying, so I'll do the opposite, I'll divide. That's the way I like to write it. Have to do it on both sides. 3 divided by 3 is 1, isn't it? So you could write a 1, but remember the point of this was to get rid of anything in front of x. And 1 times x is just x. So there it is. The answer is x equals 12. And if we take 12 and put it back into the original equation, for x, we'll have 3 times 12, which is 36, plus 7, and that does in fact equal 43. So this is the one and only solution of this equation. Now I want to give you a little hint in problems like this. They're going to get longer than this, and they're going to get messier. So let's plan for that and line up your equal signs. See what I mean? See how I've lined up the equal signs? that'll kind of organize my problem, so I won't be adding two things on the same side. Always one on one side and one on the other. So please line up your equal signs.
Thank you, sir. May I have another?
Okay, let's try another here. Now we have two troublemakers, 2.6 and negative 5.2. Think about it. Which one are we going to get rid of first? We're going to follow the order of operations backwards. 2.6 is multiplying, and the 5.2 is subtracting. So the order of operations backwards would have us get rid of the addition and subtraction first. We'll get rid of subtraction with addition. Of course, I have to do it on both sides. And I compute. The 5.2's go away, and I get 2.6b equals 23.4. Now, I got to get rid of that 2.6. He's multiplying, so I'll divide. Got to do it on both sides. Doing the division, I won't do that for you here. I'm going to get 2.6 divided by 2.6 is 1, isn't it? We don't write the 1. We say b, in this case, is 9. And that son of a gun is your solution, and your one and only solution to this equation.
Now what am I gonna do?
How about this one? Now this one has two variables. We need to get the variable alone, but we can't get both of them alone. So what we do here is combine them. And I want to show you two kinds of combinations. When two things are on the same side of the equal sign, for instance, these two numbers are on the same side, you can just put them together. But when two things are on different sides, for instance, the minus 2z and the 3z, you can't put them together because they're on different sides. So guess what we have to do? We have to kill one of them. Here's one way to do it.
Holy heart failure.
Well, we have to decide which one, and I'll tell you, it really doesn't matter which one. There's one easier way, but it really doesn't matter.
Wait a minute, 99. That gives me an idea.
I'm going to kill, in this example, the 3z by subtracting 3z. Of course, if I do it on that side, I have to do it on the left side, and I can only do it to who he's a like term with. So I like to line it up with the minus 2z. See how the 3z's go away? I've actually killed one of them, and I don't want to say I brought it over. I added its opposite to the other side. Now, 37's not a troublemaker. I have two troublemakers, minus 5 and 7. And which do I get rid of first? I hope you know I'm going to get rid of that 7 first. I'm following the order of operations backwards to get the variable by itself. Do it to both sides. Now all I have to do is get rid of the minus 5. Be careful here. There's not going to be a plus 5. That minus 5 is multiplying. So I divide to both sides. And I get, son of a gun, z equals negative 6. Recall that 30, positive 30, divided by negative 5 is negative 6. So that's how you do it when you have things on the same side that are alike, we combine them, and then on different sides, we kill one of them. I have one last tip I want to show you about a problem like this.
Wait a minute.
We have some options, and let's put those options to work. First of all, I'm definitely going to put the 42 and the minus 5 together first. So that's the same. But at this point in the problem, last time, I subtracted a 3z from both sides. And that's fine, and it worked out. But it led to a negative number. I don't mean a negative answer, I mean dividing by a negative number, and many of us aren't very good at that. Another option is, since it doesn't matter which one I kill here, I always tell people, always pick on the little guy. Always pick on the little guy. Usually you can beat him up better than you can beat up the big guy. Who's littler here, minus 2z or 3z? Certainly the negative number is littler. Watch what I do here. Instead of killing the 3z, I'm going to kill the minus 2z by adding a 2z. Of course, if I do it there, I have to do it on the other side. Seems fair, doesn't it? Now, the 7 isn't bothering me at all, is it? I have two troublemakers, two different troublemakers, the 37 and the 5. But I don't have a negative 5. So if you pick on the little guy, you won't end up with a negative, per se. You may get a negative answer, but you won't end up with dividing by a negative, and that's going to be an advantage in the future. Now let's get rid of this 37 by subtracting 37 from both sides. I'll get a negative 30. Now what do I have to do with this 5? He's multiplying, so I'll do the opposite. I'll divide. Got to do it to both sides. And I get z, of course I get the same answer, z equals negative 6. Always read the variable first. Get used to that. That'll be important in later chapters when we talk about inequalities. Okay, so what I'm saying here, you're going to get the same answer anyway. So since it doesn't matter, and as long as you treat both sides the same, always pick on the little guy. That's going to help you later on. Okay? And always line up your equal signs. See what I mean by starting to get messy? Line up your equal signs.
Excuse me, Professor Brainiac.
Okay, let's talk about parentheses in these equations. We know that we're always going to want to try to get the variable alone, and of course, as we just showed you, we're going to use the order of operations backwards to do that. But we really can't get the variable alone until we only have one variable. So, before we did that, you may remember, we narrowed the problem down to only one variable, and my hint to you, you may remember, was to get rid of the smaller one. That way you won't have any negatives. Now, if there's a bunch of variables, it's going to behoove us to combine like terms so that we only have to get rid of one of them. So we'll combine them before we try to narrow the problem down to only one variable. But we can't combine like terms if there are parentheses. So actually, the first thing we'll need to do is remove parentheses using the distributive property. So the order that you're basically going to do equations that look like this is, first, we're going to remove the parentheses using the distributive property. Then, once we've done that, we'll combine like terms. And once we've combined like terms, we'll have basically only one variable at worst on each side. And we'll narrow the problem down to have only one variable by subtracting the smaller one or getting rid of the smaller one. And then once we only have one variable, we'll get the variable alone.
Holy cow!
We can do it.
Pay attention, boys. I'll show you how it's done.
Let's try one. First step, remove the parentheses using the distributive property. Now let me begin. On the left side, I'm going to distribute that 3 to what's inside parentheses. And I'll get 3 times the x, and basically 3 times a negative 2. So I have 3x minus 6, and I bring the minus x down. Now on the right side, I'll distribute the 2 to what's inside parentheses. 2 times 2x, and 2 times 1. And as you can see, I have now removed the parentheses using the distributive property. The next step would be to combine the like terms on each side. On the left side, the 3x and that's really a minus 1x can get together and become a 2x. And on the right side, I only have 1x, but I can put the two constants together, the 2 and the 8,
You'll come again.
and we get 4x plus 10. Okay, we've combined like terms. Now we need to narrow the problem down so that there's only one variable. And I like to get rid of the smaller one. So in this case, on each side, I'll subtract 2x. And I get minus 6 on the left side and 2x plus 10 on the right side. And now I only have one variable,
I know that, dude.
and we get that variable alone. Now who's keeping him from being alone? The 2 and the 10. We're going to get rid of the 2 and the 10 in the backwards order of operations. So we get rid of the 10 first. He's adding, so I'll do the opposite and subtract 10 from both sides. That leaves me a negative 16 on the left and 2x on the right. Now that 2 is multiplying, so we'll undo him with division to each side. And finally, x will equal, it doesn't matter which side x is on, by the way, as long as it's alone. X will equal negative 8. And getting the variable alone, well, that was our... Now, while they won't get much harder than this, they won't get any harder than this, they will get a little bit weird. And I want to show you a trick of mine when they get weird using the word when. Let's look at the first one. This one isn't quite that weird. Just a regular old equation. We're going to try and figure out what z is. First, let's only have one z, so we'll subtract the smaller one, 3z from both sides. And then we'll get the z alone by adding 7 to both sides and dividing by 4. And one could say that this equation has a solution when z equals 3.
Well, duh.
I know that seems simple, but the word when is going to come into play later. Consider this equation. Once again, what are we going to do? We're going to try and get it so we only have one letter. So we'll subtract the smaller one. Well, they're both the same. So we'll subtract 7z from both sides. But now look what happens.
Now what am I gonna do?
All the letters went away. Well, bring in your old buddy when,
A clue!
and consider that this equation has a solution when 7 equals 5. Well, when does 7 equal 5? It never does. So actually, there is no solution to this equation, or we write no real solution. A little weird, huh? This word when will help us whenever it gets weird. For instance, let's look at this one. Once again, we're going to try and get it down so we only have one letter. We'll subtract 7z from both sides. But in this case, once again, the letters went away. Let's again consider our old buddy when.
Here I come to save the day.
When does 7 equal 7? Well, it always does. 7 always equals 7. So this equation has a solution when 7 equals 7. Well, all numbers will fit in other words. There's an infinite number of solutions. No matter what number you put in for z, it's going to work. So using the word when, I would argue, is going to help you out when things get a little bit crazy. Now,
Pay attention, son. This is for your own good.
one last thing, and probably the single most common mistake in all of beginning algebra, is not being able to tell the difference between the following two things, if you would. Now, take a look at these two. You taking a look? What's the difference between these two groups? Well, the one on the left has an equal sign. And since it has an equal sign, we know that it has a left side and a right side. On the other hand, this group on the right does not have an equal sign, So really, there's no left or right side. It's just a bunch of terms. If we have an equal sign, we're going to call what we're dealing with an equation. You knew that. If we don't have an equal sign,
Well, ooh-la-dee-da.
well, we have to have a different name for it, so we'll call it an expression. Big difference between an equation and an expression. Why do you care? I'll tell you why you care. Because with an equation,
You are correct, sir.
you're going to solve it. And when you solve something, you take action in pairs. Every time you do something on the left side, you have to do it on the right side. That's with an equation. For instance, notice we're doing this twice, subtracting 3z from both sides. And then we're doing this twice, adding 7 to both sides. And once again, doing something on each side. Because there's an equal sign, there's two sides, and we do everything twice,
I gotcha.
and we get the answer. A lot of people try to do that with an expression, and that's where they're wrong. With an expression, we're not doing things twice. We're not solving, we're actually simplifying. Basically, all you're doing is adding like terms. For instance, 7z and 3z. We didn't do anything twice, we just combined them, you see. And the minus 7 and the 5, we're not doing anything twice. We're just combining them, and guess what?
And that's all she wrote.
You have to stop there. You have to know when to stop. So what's going to decide with whether you solve something or simplify something, or whether it's an equation or an expression?
You're absolutely correct.
Of course, it's the equal sign. So be aware, when you have an equal sign, you're going to solve an equation. When you don't have an equal sign, it's an expression, and you're going to simplify it. Now,
Does everybody know what time it is?
go do your homework. Get it all done.